This is Mr. Cappert. This goes with the Truss Bridge project. Just want to talk about how the shape of a structure influences its strength. So I want to talk about fundamental structural engineering concept, the strength of shapes. When we look carefully at bridges, we can see how structural engineers use different shapes to make the overall design. We can see triangles and squares. We can even see parabolas. So notice square here, parabola here, and triangles. But notice even when you have a square, notice that they have cross beams always that divides it up into triangles. Here you have 1, 2, 3, 4 triangles. For instance, here too you could see that there's a rectangle, but they took cross bracing across there, and now you have 3 triangles that are within there. So they use the same shape in buildings as well. Many building frames are simply repeating squares as shown to the top left. The bottom left image shows how a square is reinforced by adding a diagonal cross brace in this scaffolding. Notice diagonal right there. That breaks it into 2 triangles. The image to the right shows an Arctic geodesic dome under construction. The structure of geodesic domes is similar to the structure of soccer balls and can be viewed as a group of pentagons and hexagrams. But if we break down each of these shapes, we can see that they're fundamentally composed of triangles once again. You're starting to see a pattern here, I hope. Triangles everywhere. Even when we get outside the realm of civil or architectural engineering, we can see how engineers rely on known strength of shapes. A motorcycle frame, for instance, has many triangles to support the wheels and the seats. Mechanical engineers design cranes, which use triangles and squares in their frames. Even satellites have these familiar and basic geometries. Notice again, you may have a square here, but it's bisected once again by a cross member to break it into triangles. So notice here we have 3 different shapes: a square, a diamond, and a triangle. On a paper, sketch what you think will happen to these shapes if we apply the force shown in the green. So we have this shape. Could be made out of wood or metal, and we have a force, which you guys should be learning about in physics, pressing down on it. What do you think will happen to the shape? Now notice with a square, the angles can change. Right? They are not fixed angles. So notice this structure is going to collapse to the right, or maybe it collapses to the left. Same thing with this square that was up on its edge. These angles are not fixed. However, with a triangle, the length of the sides are a fixed length and the angles are locked. So with a triangle, you're not going to have a change in shape because of the relationship between the sides. The length of the sides and the angle, they are locked. Once again, with these, the angle can change without changing the length of the side. The triangle, if you were to try to push it this way or that way, this would have to actually lengthen. It have to be stretched. So a triangle is not going to be collapsible unless you break it. And a triangle is different from the other two for that reason. And remember, like I said, the angles are fixed based on the opposite side's length. So in order for this thing to collapse, you'd have to have a situation where the side was either crushed or stretched. Unlike with these shapes, the angle can change here and the length of these would stay the same. So this is why a triangle is going to be much stronger. All these other shapes can also be deformed because the angles are not fixed. Draw these shapes in a way that will keep them from collapsing. There's a change that you can make to these to make it so they don't collapse. So what you probably did was draw in cross bracing here. You could take this square, put a cross brace across here, you have two triangles. Same thing with these shapes. You can draw in or add members and make it where it's more and more triangles. And remember, the triangle is not collapsible. The triangle has fixed length on the sides, and that side is related to the angle. They're tied together. So the only way, once again, for a triangle to collapse is if you stretch or you crush one of these members. Unlike the square, you wouldn't have to stretch or crush a member for it to collapse. And you could make this shape actually and see that, and you guys probably have done this before. If you press right here, this thing will collapse flat. You can do the same thing with a 3D structure. Notice how this is bendable, but if you add in cross bracing, if you make triangles, it makes it much stronger and it's no longer collapsible. Hope this helped. Let me know if you guys have any questions at all. But this is why triangles are used in truss bridges and other structures such as cranes.